This, yeah. Stand this. Are Penmara. Okay. So good afternoon, students. So today, uh, this is a very good opportunity to have one more time to write NEET. So this is thanks to our chairman sir to give this opportunity. And so today, so I'm going to discuss. So today we are going to discuss this photoelectric effect and also dual nature. So that is de Broglie wavelength. Let us see. So this is one of the most important topics. So every year, so 2 questions compulsory we are getting. And so let us see how they are asking, and 2 questions either from a photoelectric effect or each photoelectric effect, and one is from de Broglie, or both they are giving. So combination. So let us see, or sometimes they give what 3 questions also. One of the so important and definite questions from this chapter. Let us see. So from this year, so NEET 2026, this question asked. Let us see this question. So this is see diffraction and interference based on the conceptual. So diffraction and also interference, is this the particle nature or wave nature? So once we see the what I'm going to do is, so how they ask the questions, and how the questions they asked already, and how what type of questions so we can focus, and what type of this one word concept we have to focus more. So let us see. Yes. So let us see this one. So first of all, so this photoelectric, this diffraction and interference, let us take. Is this the, so what type of nature? Is this a wave nature it supports, or particle nature it supports? So based on this one, I don't want to discuss this previous question, but based on that one, so what they asked and what they are going to ask, and where we have to so focus this, that I want to discuss. Let us take for diffraction and interference. So is this particle nature or wave nature? One thing you have to remember, so diffraction and interference, so it supports the wave nature. And look at here, this is Another important thing is diffraction interference supports the wave nature. Okay, but so what more supports the wave nature? You have to so concentrate not only this one, what more they may ask. So that is a very important that I want to discuss today based on this previous papers. Let us take. So diffraction interference, no doubt, this one is what supports the wave nature, and also in addition to that, so it gives what diffraction and also interference. So this one, diffraction and interference, not only this one, what is this one here? Even, so this is what, let us take what, reflection and also refraction. So reflection, refraction, and also polarization. These things you must have to remember. In addition to that, based on the 2026 or the previous question papers, so they asked, okay, but based on that, what more we can this one concentrate to get so very good marks in future. Let us take what diffraction interference is the wave nature. They may ask what more, polarization, reflection, refraction. These are the 3 points you must have to add for the wave nature of light. So that you must have to remember, okay? And another important thing is Compton's effect. Compton effect, so this one is what? It supports this one is what? Particle nature of light. So not only this one Compton's effect, you must have to remember, so in addition to the Compton effect, what more they can ask. That is the most important. So Compton effect, and one more important, that is what Compton effect, so photoelectric effect. So photoelectric effect, I'll write here. So let us take photoelectric effect, and also Compton's effect. Okay, this already given, but what they may ask is what photoelectric effect and also black body radiation. So this one is what black body radiation. So black body radiation also supports the particle nature. So what you have to remember is Compton effect already given. So, but what more they may ask? One is what? Photoelectric effect. Another is what? Black body radiation supports which one? Particles nature. Okay, by using the, so Einstein used the quantum theory and explained this, this one is what? And supported the particle nature. That you must have to remember. And also, let us take what here, and lambda is equal to h by p. This I want to discuss, that is, so lambda, that is the de Broglie wavelength. So let us take lambda is equals to h by p. This is the de Broglie wavelength. Is touching this one is not only, so this one photoelectric effect, even is a combination of de Broglie is also asking. So lambda is equal to h by p. What more we can remember? So what more we can remember for this de Broglie wavelength? In asked 2026, lambda is equal to h by p. What more we have to remember? So one thing is lambda is equals to h by p or h by mv. Okay, so this de Broglie said, so whenever a particle is in motion, it is associated with, so this one is the wavelength, lambda is equal to h by p, and this already asked, what more we have to remember? That is the most important. Lambda is equal to h by mv, h by, even we can write it as what 2mke, or we can write it as what 2me also we can. So these things what you have to remember, and also root of 2m. So kinetic energy we can write it as what q into this about v or delta v, that is the potential. So this is already asked, what are the things you have to remember? So lambda is equal to h by mv, and also h by root of 2mke, and also h by root of q into v we can. And you have to remember what this one. So this is what, based on this one, you have to remember all these things you have to remember. And so let us take what for electron, what you have to remember. Many times they asked for electron, what is the de Broglie wavelength? So you have to remember de Broglie wavelength for electron, 12.27 divided by root v. This should be in angstrom. Okay, so based on this question, what more question they may ask, that I'm going to discuss. So this is for electron, 12.27 by root v. Nowadays they are asking what even. This volt means what? Even in electron volts also. You know that 100 volts is nothing but 100 electron volts. Okay, that you have to remember. So whether it is given electron volts or volts, it is what same in the CGS. That is what. So 100 volts also you can take, 100 electron volts also we can write this one. This is in angstrom. Nowadays they are asking what in nanometers. This is what for angstrom. You must be careful about that. Whenever it is what nanometer, 1.227 divided by root V. This should be in nanometers. So you must have to check while reading the question whether it is given in nanometers or angstrom. Based on that, you have to select this one. Okay, right. For now, after this, just based on this lambda is equal to h by p, what more question they may give, that I am going to discuss. That is what compulsory you will get in this one is what in NEET. So this is for electron. Then you have to think about for proton, what should be that. So what about the proton? Proton is equal to what? 0.286 by root V. This is in angstrom. Okay, you have to remember what this is an angstrom. If it is 1 nanometer, again you have to take what? So 0 point something, 0 you have to take. And this is for proton you have to take. Okay, so then what about the deuteron? So for deuterium, deuterium is, you can write as what? 0.202 by root V. And also for alpha particle also, so you can get 0.101 by root V. Those things what you get. So this is about what de Broglie wavelength. These things what you must have to remember. Okay, and also this is what one is the wavelength, and for electron and photon, that I'll discuss so afterwards. So then one by one I'll discuss these things what you must have to remember. What more? So let us take what here. Now again energy. So this is what completed because it gives what wave nature, and also this is the particle nature. So in addition to that particle nature, what more? Photoelectric effect, and also so black body radiation, in addition to diffraction and also interference, polarization and also reflection and also refraction, and also lambda is called h by p. What more things you have to remember? So h by p, h by mv, h by root of 2m ke, or h by root of 2m qv. And also for electron what? And also what about this one is what? Proton, and other thing also you must have to remember. Based on this, definitely they ask the questions. Right, and based on this is what E is equal to h nu. This is what photon energy. So energy of the photon is equal to h nu or hc by lambda we can take. This is what energy of one photon. If it is having what n number of photons, then what we can write? E is equal to n h nu or n into hc by lambda we can write. This is for energy for n number of photons. They may ask what here. So what they asked here, only E is equal to h nu they asked. And what more they may ask what here? hc by lambda, or this is what n into h nu or n into hc by lambda. So even we can write it as what here. Suppose this is what h Planck's constant they may give. So r you have to remember what 6.62 in 10 power minus 34, and also we can write as what 12,400 by lambda. So whenever you are writing what this is what E is equal to 12,400 by lambda, this lambda must be in angstrom. This should be in electron volts. This is what energy. So even you can remember what this one. So this is what this is what SI systems you can take what H and C and also lambda, or 12,400 by lambda, that must be in angstrom. Then energy must be in electron volts. We get this is the energy of the photon. Right. So this is what if n number of photons are there, n into h nu or n into hc by lambda. They may ask what about the power or rate of photo electrons are coming out, or rate of photons that coming out, rate of photons. Then we can take it as what here. So let us take what here. So this is about power. Power is equal to n energy by time. There are what n number of photons are there. Then we can write as what n into h nu by t or n by t. So number of photons so per second or rate of photons. They may ask what n by t is equal to p h nu by. So this is what h nu by p, or so we can write it as what n into hc by lambda into t, or n by t is equals to what we can write. So this is what p by t, p into lambda by hc also we can write. This is what rate of photons or number of photons emitted per second. So what you have to remember is, just you remember based on E is equal to h nu, what more questions they may ask, what are the things you must have to remember. One is what E is equal to h nu, that's already given, or they may give what here. So suppose the energy of the 12,400 by lambda, if lambda is given in angstrom, the E should be given in electron volts, and also hc by lambda lambda. If n number of photons are there, n into h nu or n into hc by lambda. So that you have to remember. And also the rate of photon, if the power is given. So the previously the asked questions are this one only, but you must have to remember only one question paper. So we'll give what so many things. This is what the way you have to. So we'll discuss here. So power is equal to n into energy by time, or rate of photons or number of photons per second is equal to, you can write that way. Okay. So this one is, so one thing, and I'll go to the next slide. So this is a very good opportunity. You have to utilize these 35 days. So, but you gave the, you got the opportunity instead of 365 days. So this one is what 35 days. Whatever the work you do in 365 days, you have to do in 35 days. That means how hard work you must have to do, you must have to remember, right? Right. Now we go to the next slide. Yes. Right. So even this question asked in 2026 in NEET. So let us take what is this question? Let us see. For a metal work function 6.6 electron volts, which of the following wavelengths of incident radiation does not give rise to the photo? This one is what electric effect. So this is the question asked. So what is given here for metal of work function? So metal of work function is given, that is 6.6 electron volt, is a 2026 NEET. So which of the following wavelengths of incident radiation does not give to the photoelectric effect? So what you have to remember, so this is the work function. Just now I told, whenever energy is given in electron volt, how do we calculate the wavelength? Of course, the options are given, so it is not there, but it is given. So this is first option 200 nanometers or 150 nanometers, 100 nanometers, and also 50 nanometers. It is given in 2026. Based on this question, what are the things you must have to remember in future that I want to give? Let us take work function is 6.6 electron volts. Then, so now how do we get the wavelength? Just now I said, whenever energy is given, so you can take it as what 12,400 by lambda, that must be in electron volt, and this is what lambda should be in angstrom, this should be in electron volts. Suppose if it is lambda is given in nanometer, particularly is given in the this one options, so this is nanometers. Therefore, if nanometers, if you take lambda is equal to 1240 by E, we have to write this should be in nanometers. Let us take what here. Then first I want to calculate. So the wave, this wavelength in nanometer I want to calculate 1240 divided by. So this is what 6.6 in electron volts is given. Let us take what here. So 12400 by 66 we can take. Okay, right. So then we can take it as what here. So this one is, suppose if it is, if you take what, so let us take what, this one approximation 126. If I take 6 ones, 6 twos, 610. And also we can take it as what here, 11 ones, 11. So 11 nines, so this is around 190. That means what? Of course, we took what more here. That's why this value should be less than this. So let us take what around 180. So this is what 180 nanometers. So this is the wavelength 180 nanometers. But we know what are the things you must have to remember based on this 2026, what he's testing and what he may ask for the next coming this one exam. That is the most important. So now look at here. I don't want to discuss about this previous paper, but based on this one, what are the things you will get and what are the things you must have to concentrate, that I want to give. Let us take, so in this photoelectric effect, what are the things you must have to remember whenever, so this one it is suitable frequency or energy, so energy or frequency and wavelength is falling on the, so this one is what metal surface, then work function is what W and threshold frequency, and also this is the wavelength. So according to this one is, so whenever this energy, whatever the energy is what falling on the metal surface must be greater than the work function, then only you can get, so photoelectrons are ejected out. E should be greater than W. What are the things you must have to remember? You must have to remember. So they may ask what? Energy, whatever the energy falling on the surface must be greater than the work function. This you must have to remember based on this question what they asked. Right. Then this one is what first one. And also the frequency of light falling on that must be greater than the threshold frequency. These are the things you must have to remember for the coming NEET. Then based on this question, what they asked. So I am not giving what the solution, what while giving what solution, what questions they may ask, what are the things you must have to remember, that I'm explaining here. Then, so and the third one is, so here wavelength. That wavelength is more means what its energy is less, but whatever the energy falling on, that should be this one is what energy should be greater. As energy is what greater means wavelength should be lesser. Therefore, lambda should be less than the threshold wavelength. As lambda is what less, whichever the wavelength is falling on the surface, if it is less, then its energy is more. That's why wavelength should be more. This is what less. That means what? So we can say what is the work function definition? Minimum energy required to excite the photoelectron, and also threshold frequency is the minimum frequency, whereas what wavelength comes to wavelength, it is the maximum wavelength. So that means what? This should be the maximum wavelength that we can. So what about the maximum wavelength? So maximum wavelength that I got here is, now come to 2026, then whatever the maximum wavelength that you have to, so we got it is 180 nanometers. That means that should be the maximum. If it is what beyond that, you cannot get the any photoelectron. Now come to the question and the answers. Then what is asking here? So does not gives rise to photoelectric effect. So if it is what less than that, if the wavelength is what less than this, energy is what more. As energy is what more, then you can get the photoelectrons. But what we have here is what less energy is what, so less only we can get the photoelectron. Even this wavelength is what less than this one, yes, you can get the photoelectron. Even this wavelength is also less than this one, yes, you can get the photoelectron. So that's why, but he's not asking what gives rise to, he's asking what does not give. This is what most important, does not. So which one? So it should be more than that. Then you cannot get the any photoelectron. That's why what is the correct answer? These are not. Therefore, then what is the correct answer in 2026 is what? 200 nanometers. Have you understood this one? This is the very important. So once just go through that, then we go to the next slide. Yes. So this is the most, and one more important point that I want to give, that is photoelectric effect. So this one is what you know, the photoelectric equation, that is H nu is equals to W plus Ke max. This is the most important, Ke max. So it's not Ke, it should be Ke max. So according to this photoelectric effect, you must have to remember what are the things you have to remember. So based on this one, photoelectric effect is, first one is it supports the particle nature. So Einstein explained this one is what photoelectric by using a quantum theory. So this is what particle nature supported. Okay, and one more thing is what? Energy is conserved. Yes. And also one more point you have to remember, this is what? Energy is what conserved in this. And also this photoelectric effect takes place with the bound electron. Okay, so you must have to remember. Whereas the Compton effect, of course, is not there. Compton effect is what? With the free electron. Then photoelectric effect, because complete, so energy is what? Absorbed. So it is what? So this photoelectric effect is what? With bound electron takes place. That means what? Photon. So this one interact with the bound electron. Okay, so this you have to remember. So one more important point you must have to remember, photoelectric effect takes place with the bound electron and energy is conserved. Then, so now we go to the next part. Let us take, even by using the Planck's constant also we can take, by taking what? H and C and also lambda, you can get that. Now, let us go to the next slide. Let us take what this is 2024, that same type of things I kept here. C is the velocity of light. So energy of photon. So now look at here, energy of this is 2024. Let us take the energy of photon is equal to h nu. So already they asked what one more, this one 2026 question also they asked what E is equal to h nu. Okay, right. So again this one, the velocity of the photon is, this one is what? Moves with velocity of light, and rest mass of photon is what? 0. That means what it is. So it won't be at rest. So it is in motion only. We have to take the momentum of photon. So momentum P is equal to h nu. That is equal to what we can write here. So E is equal to h nu or hc by lambda. then we can take it as what here. So even, so let us take what even this is equals to, even momentum is what, momentum P is equals to what we can write here. So this is what h nu we can write, of course. So this already E is equal to h nu. Then so mc square is equal to h nu, or mc is equal to h nu by c, or momentum is equal to h nu by c. Even this is also right for the momentum, right? In photoelectron collision, both total energy and total momentum are conserved, right? Okay, because whenever it is what photoelectron collision, so whenever electron so hitting what this one, so the photon hitting the electron, then the energy and also the momentum is conserved. And photon possess positive charge. Photon do not have what any charge. That's why this is what not the correct answer. The correct answers are A, B, C, D. Okay, so these things what you have to remember. So let us take, this is what the simple way they ask the questions. Okay, right. So should we go to next slide? Yes. So simple things you have to remember in this based on the theoretically they are asking, and about the photoelectric effect. Yes. Next come to another one. Yes, this question you see, let us take, so previously this asked here. So the light of frequency 1.5 times the threshold frequency, this is 2020. So is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved and intensity is doubled? One important point in photoelectric effect. So then what should be this one? This energy and also frequency and also wavelength. And this is what work function, threshold frequency and also threshold wavelength. Then now, so whenever this one is the light of frequency 1.5 times the threshold frequency, that means, so whatever the frequency is, this is threshold frequency, whatever the frequency falling on that, it is 1.5 times. That means whenever frequency of light falling on the metal surface should be greater than the threshold frequency. That must be the first condition you must have to remember. So energy should be greater than the, so this one is what? So the work function or frequency falling on that should be greater than the threshold frequency. That should be the first condition. So intensity is what? So afterwards it comes. But first should have to satisfy this condition. After that only we go to the intensity. Let us take what intensity is given I here. Then so now, so let us take what is, this is what photoelectrons are emitted, because frequency is what more than this threshold frequency. Now what is saying, so let us take what will be the photoelectric current if the frequency is halved and intensity is doubled. So frequency is halved. Once frequency is halved, it becomes what? 0.75 nu naught, and intensity is what? Doubled. So then this is what threshold frequency. Now it comes to what in the second case, whenever frequency is halved, then what happened? So this frequency is halved. Whenever frequency is halved, it is what? Less than the, whatever the frequency is falling on the metal surface is less than the threshold frequency. Once if it is what? Less than the threshold frequency, even though intensity is what? Doubled or tripled, so you won't get the photoelectrons. That's why how many photoelectrons are comes out here? No photoelectrons are comes out. This point you must have to remember, because so whatever the energy falling on that, sufficient energy, suitable energy must have to fall on that. If that energy is what? Not provided, so immediately you cannot get the photoelectrons. So this you must have to remember in this. So it should be not the intensity, it should be the frequency should have to so satisfy. These things what you have to remember in this. Okay, that's why the answer is what? No photoelectron. That's why the answer is 0. Right. So these things what you have to remember whenever this is about energy. How it is what? Number of photoelectron, how do we get, or energy of the photoelectron. So all these things we'll discuss. So one by one, let us see. Now, so comes to this one. So let us take the work function of cesium and potassiums are given. So let us take what different surfaces are given. Let us take what cesium. So and also this one is what? Potassium is given, and also this one is what? Sodium is given. So their work functions are given. So what about the work functions of this one? 2.14, and also this is what? 2.3, and also this one is what? 2.75. These are the work function. So incident electromagnetic radiation has an intense incident energy. Whatever the energy is falling on these three surfaces, different surface, that's why they have what? Different work functions. So, but on these three different surfaces, so same energy is what falling on that. So what about same energy? Energy is what 2.2. So which of these photosensitive surfaces may emit photoelectrons? This is 2.2, this is 2.2, this is 2.2 is given. Then, so what we get, look at here. Just now I said, whatever the energy, just now I gave, this is what energy, this is what work function. Whatever energy falling must be greater than the work function. Just now, previously what they asked, so about the frequency they asked. So frequency should be greater than the threshold frequency. Similar way, they asked in this. So energy should be greater than the work function. Then only photoelectrons are emitted. What about the energy of, so light that is falling 2.2, but, so here is what, let us take what first second one we take, 2.2 and this work function is 2.3, but this energy is falling is less than the work function. You cannot get the photoelectrons here. And even here, so 2.2 energy is falling, but what is the work function? 2.75, which is what? So less energy is falling on that. That's why you cannot get photoelectron. Therefore, so you can get the photoelectron. This is what? 2.2 is what falling on this one. This energy is what more than the work function. That's why from cesium we can get. So this one is what photoelectrons are emitted. So this one is what you must have to remember. That's why what you have to remember. Energy should be this one. Frequency should be this more. And also wavelength should be less than this. So these things what you have to remember. And in 2026 they ask what about the wavelength, and they may ask what other things what here. Okay, so this one we move on to the next slide. So these things what based on this one they are asking. Very simple. Okay, let us see another way. Next slide, we go to the next slide. Let us see. So you must have to remember, so this one is what? So he's asking which of these photosensitive surface may emit the photoelectron. So let us take what if they ask what? May not emit the photoelectron means what? Both sodium and potassium. Okay. May not. That's why you must have to remember may not is given or may is given. If it is may not, the answer should be sodium and potassium. Next slide. Yes. Now, so wavelength of numerical. Now this is what 2024, what they asked, you have to remember. This one is, let us see. So wavelength of numerical value of this one is meters is incident on it with the energy above its threshold value at an instant. Then the maximum kinetic energy of the photoelectron ejected. So by it at that instant. So C is the velocity of light, and this one is it's C by E. It is given. And let us take what maximum kinetic energy of the photoelectrons. That is what? So coming out by that instant. So let us take what wavelength of numerical value is what given. And so HC by this is what given. And also is asking about what about maximum kinetic energy of the photoelectron ejected by it at that instant is asking. So what you have to remember, one important point I'll give. So whenever this is what, let us take what here, this is what energy. And what is the work function here? W. Then what about the maximum kinetic energy of the this one is photoelectron coming out is Ke max. Let us take. Then what about the now one example I'll give. Let us take what 10 electron volt energy is what falling. Then the work function is let us take 4 electron volt. And what should be the maximum kinetic energy of the photoelectron that comes out? Maximum kinetic energy of the photoelectron that comes out. Let us take. So how do we get this one? There are two questions I'm asking. One is, what is the maximum kinetic energy? Or let us take what here? What is the kinetic energy of the photoelectron that comes out? This is very important. You must have to remember. Whenever energy falling on the metal surface is 10 electron volt and what is the work function is 4 electron volt, then what should be the kinetic energy of the photoelectron that comes out? Whenever they ask what kinetic energy, so you cannot take the energy falling that is 10 and work function that is what 4, then kinetic energy is 6 electron volt. This is not correct. Because whenever I ask what kinetic energy, you must have to take what from where to where? 0 to that one. Therefore, kinetic energy energy, so that is what coming out is 0 to 6 electron volt. Whenever I ask what is the maximum kinetic energy that comes out is 6 electron volt. Therefore, what about the maximum kinetic energy? Whenever they ask, you must have to subtract. That's why. So what this Einstein said, this is what h nu E is equal to. So let us take what R hc by lambda is equal to W plus Ke max. This is whenever, so even 0 to 6 if it is given, you must have to take as what 6 as the kinetic energy maximum, then we can go for that. So even this also we can take what here. So what about the energy is what Ke max. So Ke max is equals to what we can write. He's asking what about the Ke max, that should be equal to energy minus this about the work function we can take. So okay, so like that work function is given what 5, so then we can take it as what E is the energy. So what about the energy is what falling in this is what Ke max. So this Ke max is equal what the energy is what falling, lambda is equal to hc by E means what about the energy is equal to hc by lambda, that is what E. And also what about the work function of this one is what given. So this is about work function, of course, that is what work function is phi is the work function as it is what mentioned. This is what, so not mentioned, E minus phi. This is the maximum kinetic energy is what energy minus. So this one is, so the work function we can take. So here the most important point you have to remember, whenever they ask what kinetic energy, you must have to take what 0 to that. Whenever they ask what maximum kinetic energy, you must have to take what only that particular value you have to take. Okay, so this one is, you must have to remember here. So work function, so given should be given, that is what as a phi. So this one you have to remember, whenever they ask what like this, should be careful about this maximum kinetic energy or of mv square or like this. Now we go to the next one. Even this is also the same thing, it is given. Okay, right. Next one, let us take the maximum kinetic energy of the emitted photoelectron is photoelectric effect is independent of. Now look at here. So whenever you must have to remember one important, see, this is what energy is what falling on that. So this is the work function, this is energy, and photoelectrons are comes out. So what you have to remember, how to, this one is what, this energy of the photoelectron depends on what? This is a very important. And also what is asking, energy of photoelectron, what is asking, kinetic energy of emitted photoelectron depends on or independent of or depend on. So like that they may ask. You must have to remember, energy of photoelectrons, energy of photoelectron depends on which one? Energy is related to frequency, related to wavelength, related to stopping potential. So this one you have to remember, energy of photoelectron is this is what? Proportional to frequency, proportional to, this one is what? Here wavelength, so inversely proportional to wavelength, and also proportional to this one is what? Stopping potential. So this is what related to that. But so one more important, the intensity, or we can say what? Number of photoelectrons. Number of photoelectrons is directly proportional to which one? Intensity. Intensity related to which one here? Current, photo current we can say. And also intensity is inversely proportional to square of the distance, where d is the distance between source and the surface on which the this one is what light is falling. Then this is about what? Photo current, and this is what? Number of photoelectrons, and this one is what? Energy, and between these two no relation. So that means, suppose if I ask what intensity of incident light is doubled, then what happens to the energy of the photoelectron? No change. Okay, and if the frequency of incident light is what? Doubled, what happens to, so this one is what? Number of photoelectron, there is no change, because so here is what? Energy, this is only related, this one is only related, and between these two is what? No relation. So based on that only is asking. Let us take what here. So what is asking, this is what? Kinetic energy. You must have to remember about this one. So this is what? Kinetic energy, and it is what? Independent. Independent means what? Now look at here, energy depends on frequency, wavelength, and stopping potential. Let us see. So work function, so of a metal, so the kinetic energy is, yes, this is about kinetic energy is related to which one? Energy or work function, it is what? So this is what related. Okay, it depends on that one. And also intensity of incident radiation, this is about what? Intensity. Number of photoelectron, this one is what? Depends on intensity but does not depends upon the energy. And also frequency of incident radiation, yes, energy depends on frequency, energy depends on on work function, and also depends on even wavelength. It depends on this one, this one, this one. But so this one is what? Does not depends. That's why number of photo, this one is what? Number of photoelectron depends on intensity, whereas energy so does not depends upon intensity. So this must have to remember. And in addition to this, based on this one, they may ask what one question. Let us take what they may ask. Look at here. For example, so let us take what this is what frequency of light is falling on that. So this is the work function, and this is what maximum kinetic energy of the photoelectrons comes out. Let us take this is the frequency. Now, if the frequencies were doubled, so as the frequency is doubled, what happens to its kinetic energy? So can we say doubled? So this is what not directly it is what related, because h nu is equal to W plus Ke max we have. As this frequency is doubled, we may not take what here directly it is what kinetic energy is what doubled, because the work function is there. So that's why you have to remember. So let us take what if frequency is doubled. Directly we cannot say what kinetic energy is what doubled. So you must have to remember, if frequency is double, what happened to the energy? Energy, kinetic energy is what? More than doubled. That you must have to remember. It should be what? More than doubled. Okay, even. So how do we get this one here? So suppose if the frequency is doubled, W. So work function does not, this one is what? Depends on intensity. That means, look at here. Whatever this one is what? Energy is what falling, whatever frequency, what about wavelength is falling. So this work function does not depends upon so energy falling on that, or wavelength falling on that, or frequency falling on that. Work function depends on nature of the material, and also temperature, and also this one is what? So temperature, and also this one is what? Nature of material. So that then one important point I can give. So look at here. So work function. So this is about the work function. What is the work function? Minimum energy required to excite the photoelectron. So in alkali metals, if you check sodium, potassium, rubidium, cesium. So whose work function? They may ask what question in future or next exam. So let us take what here work function. So work function depends on which one I said. So nature of the material, sodium, potassium, rubidium, cesium. So which one is what? So this one is what? Which one is the best for this photoelectric effect? And easily to get photoelectron, that is the best metal. So as the cesium is what? Atomic radius is what? More. As atomic radius is what? More. Then whatever the electron is there, it is not this is what? Not so that much is what influenced with the this nucleus. That's why less energy is required to get that photoelectron. That's why cesium is required less energy to excite that electron. That's why its work function is less. As its work function is less, it is what? Good for photoelectric effect. They may ask what question in the coming exam. So that is what? So work function is what? Least for which one? Cesium is the least. Not only least, cesium, and is the best for so photoelectric effect. As work function is what? Least, then much energy is utilized to get the photoelectron. That's why cesium is the best one. So we can say. So that's why what you must have to remember, work function depends on which one? Nature of the material. As the atomic mass number is what? More, its work function is less, because energy required is what? Less to excite. So, and another point is what? Even temperature depends. So as the temperature increases, so this whatever the electrons are there, so it is what? Excited. So whatever already it's excited, whatever energy is what you are giving onto the metal surface is less it takes. So that's why its work function is what? Less. So that's why as the temperature increases, its work function decreases. As atomic radius increases, its work function decreases. So this you have to remember. That's why cesium is having what? Least work function, is the best for photoelectric effect. So this one is what? Work function. So does not depends on energy or frequency or wavelength. Okay, so it depends on which one? Nature of the metal surface only. Now that's why as the frequencies were doubled, this is what Ke max we can take. What about this one is what? Ke max. Now wherever h nu is there, if I substitute 2 times of, instead of h nu I can substitute W plus Ke max I can substitute. So that should be equal to W plus Ke max we can write. Or so this is what? 2 times of Ke max. So this is 2W, and if you take this side, W is equal to Ke max we can take. Or so this one is what? So this is what? Ke max. This is about Ke max is equals to this one is what? 2 h nu. So this is what? What we can write? So let us take what here. Then So let us take what H 2h nu is equal to W plus K max as the frequencies were doubled. So as frequency double, wherever H nu is there, W plus K max plus W plus Ka max here, and this is what 2W this is. So let us take what here, one second. Yes. Now, so this is what 2W plus 2Ke max. So minus W should be equal to Ke max dash. Now we can take it as what Ke max dash is equals to what we can write 2Ke max plus W we can write. That means what here? As the frequency is double, this Ke max is more than, so this is about what doubled we can say. So that's why what you have to remember, you need not to remember all this thing. You have to remember as the standard point, as the frequency is double. So this about Ke max is more than double, but not exactly double. So that you have to remember. Even wavelength is what halved. Even wavelength is halved. Kinetic energy is also more than double. We can take part like this only. These things you must have to remember as far as what this photoelectric effect is concerned. So definitely you get the question. So definitely this one photoelectric effect 1 and de Broglie wavelength 1 question we get. Yes. And the next one, so these things, light rays having photons of energy, this one falling on a metal surface, work function. The stopping potential of the surface is very, very simple. So let us take what in this. So here, whenever this is what falling 4.2 and work function is given 2.2, what about Ke max? So Ke max, also we can write it as what here. What is Ke max? 4.2 minus 2.2 is equal to 2 electron volts. But he's asking about stopping potential. Ke max also we can write it as what EV naught or Vs also we can take as the stopping potential, which should be equal to 2 electron volt. Therefore, stopping potential is equal to 2 volts we can say. This is about stopping potential. Very simple this one. K max is what equals to, you can write it as what EV naught. Okay, so we move on to the next slide. So this is, so let us take what this one is what simple thing. Like this they are asking what questions. Let us see. We go to the next slide. Let us take even. So this one is also very simple. This one 2022 threshold frequency of photoelectron. This is what nu naught. A light of frequency 4 nu naught is falling on that. The maximum kinetic energy of the emitted photon. Very simple. Okay, this one is what you can write. Ke max is asking. Therefore, Ke max is equals to R. 4 H nu naught is equal to H nu naught plus Ke max. So from that we can get what Ke max we can get. So just you take part this set, we'll get the answer. Okay, this is what very simple question they are asking. So previously they asked what about stopping potential? Stopping potential we can write as what EV naught. We can write that. Okay, and even about the graphs also we can see. Then we move on to the next slide. Right. Next one. Yes. Even, so this one, when two monochromatic light of frequencies nu and nu by 2, let us take what this one is what nu and this one is what nu by 2. So this one is incident on a photo metal. Their stopping potentials are Vs by 2. This is Vs. Then the threshold frequency for this metal is, I already, as I told, that is what frequency, so does not depends upon the work function. Work functions are same for both because same metal only but different, so they are falling on that. Then we can take it as what H nu is equal to W plus Vs by 2 or H nu by 2 is equal to W plus Vs, and is asking about which one. So this one is asking about threshold frequency is asking. Threshold frequency means what we can write? H nu is asking. Even we can write it as what this is what H nu naught, or this one is what H nu naught, equate for this. Or if you multiply this one is what with the 2, so we can get. So as we can multiply with the 2, then we can equate. That is what if you multiply with 2, 2 H nu is equal to 2 H nu naught, then Vs, and also H nu by 2 should be equal to H nu naught plus Vs. And if you subtract this one, so this anyhow gets cancelled, we can get. So this is about what? So you will get what nu naught we can get. I've understood this one. So like this we can calculate this way. So these things what you have to remember, what is given when two monochromatic lights of frequencies, so nu and also nu by 2 are incident on a photometal, their stopping potential, okay, becomes Vs by 2. Yes, so stopping potentials are Vs by 2 and also given Vs. So just write the equation, because this is what EV naught we can write, or this is what E also we can write. So then H nu is equal to, you know, the W plus EV naught. So where W is equal to H nu naught, and solve this one, we can get this. Just based on the, so this one is what photoelectric equation, it is what based. Right, understood? So just you can solve this one, you can get 2 minus 1 by 2 becomes what? It is, so 3 by 2 we get. Okay, so 3 by 2 is equals to this one we get 3 by 2 H nu should be equal to, we can write it as what here, H nu naught, then HH gets cancelled, then we can take it as what? Threshold frequency we can write. Understood? Yes, we move on to the next one. Next slide. So this is what based on, so simple things they're asking, so based on the photoelectric equation. Yes. The next one, so let us take, yes, this, let us see, this one is what? What about this one? Number of photons per second. So previously in 2026, he asked what E is equal to H nu. But as I told, based on that one, what they may ask here, so number of, what is asking? So let's check what number of photons per second. So power is equal to N times of H nu, or we can write it as what? By T, that is what energy. If this P is equal to N into E by T, we can write, or E is equal to H nu we can write, or P is equals to, we can write it as here, N into Hc by lambda T, or so rate of photons or number of photons per second should be equal to P lambda by Hc we can write. Just to substitute this rate of photons we can. So P is given as 3.3 into 10 to the power of minus 3. Units must have to check, because number of photons is asking means what? The SI system should be in watts and the lambda should be in angstrom, but it is given nanometers is given. So you have to change. Nano means what? Of course 10 to the power of minus 9 by, so H is 6.6 into 10 power minus 34 into 3 into 10 to the power of 8. So this is what 2 times, and this becomes what 6, this is what 100. So now we can take it as what? Minus 34 and 10 to the power of 8, and this becomes what? Minus 12, and this one is what? 10 to the power of minus 10, and this becomes what? 10 power minus 26. It comes to a numerator, it becomes what? 10 to the power of 16 you get. This is rate of fission or number of fissions, so per second we get. So this one you have to remember, this is what? So number of photons is asking in 2021 they asked. Okay, right. We move on to the next slide. Now, let us take, so the work function of a photosensitive material is this one, the longest wavelength of light that can cause photon, so emission from the substance. This is what exactly similar to which one? 2026. So that's why just you see, so work function is given as, so 4 electron volts. Is asking about what about the, so longest wavelength of light that can cause photo emission. And in 2026 what they asked, which of the following does not give the photoelectric effect is given. That's all. So what you have to remember, W is equals to, you know, let us take what? 12,400 by, so this is what? 4. Of course it is given in nanometers is giving. That's why you can take it as what this is. So this should be in lambda, should be in angstrom. Now it is in nanometers, means 1240 by, what about the energy? Energy is, it is what? 4. Then we can take it as what? In nanometers we get 4 3s are 4 1s are. That means what? 310 nanometers. This is what? Maximum wavelength. So that can, so below, this is what? Maximum wavelength is, this one is maximum wavelength. So the whatever the wavelength is falling on that must be less than this. If it is what? More than that, you cannot get the any photoelectrons. So 2026 asked this only, but here is asking 2019 asked which one? What is the maximum wavelength only asked? This is the maximum. So suppose which of the, this one is what? Longest wavelength that can cause the photo emission means what? Longest wavelength. Of course, this is about what? Longest wavelength 310. Okay, so that's why this is the longest. But below this, we can get the photoelectron, but above that, we cannot get any photoelectrons. That you have to remember. Okay, right. So this is next, we move on to the next page. and we go to even some graphs also. Right. Now, so let us come to this one. So this, when light of frequency, this one is incident on a metal plate, the maximum velocity of the electron emitted is V1. So simply this is what 2 nu naught and threshold frequency nu naught. Of course, this frequency is more than this this one threshold frequency. Definitely we get the photoelectron, but this is given as what velocity is V1. Now this is what 5 nu naught and the work function is same metal. So as this is what same metal, the work function is what same or threshold frequency is same. Then this becomes what V2. Then ratio of V1 by V2. Very simple. So H into 2 nu naught should be equal to H nu naught plus half mv1 square. Then same way H into 5 nu naught is equal to H nu naught plus half mv2 square. If you take what one side, don't take the ratio. After taking what this side only, you have to take the ratio. 2H nu naught minus H nu naught. H nu naught is equal to half mv1 square. And if you take this side, 4H nu naught is equal to half mv2 square. Now you have to take the ratio. Then you will get, so the V1 by V2, we can get the ratio. Okay, as half m cancel, H nu naught cancel, V1 by V2 is equals to 1:2 you get. Okay, that way we have to remember. Okay, we move on to the next slide. Right. Even this is also the same thing. So whenever this is what stopping potential. So let us take what here, illuminate with the radiation of wavelength lambda. Stopping potential is what V. Okay, this stopping potential is the same surface. Same surface means what? Same work function or threshold frequency. So this is how much it is, what? 2 lambda, and stopping potential becomes what? V by 4. Then what about the threshold wavelength is asking. So what we can write? So this is what Hc by lambda is equal to Hc by lambda naught plus EV we can write. Even Hc by 2 lambda is equal to same thing, this one, plus E into V by 4. So this type of question they are asking what? Many times. That's why what is asking? Threshold wavelength is asking in terms of lambda is asking. This lambda naught is asking about in terms of lambda means what? This should not be there. This should not be there means what you have to do? We have to multiply with 4. If I multiply with 4 this equation, then it becomes what? Same as what? EVs are same, they get cancelled. You get answer is in terms of lambda naught we get. Okay, so these things you have to remember. Understood? Right. Now, so I think what you can get this one, 4 cancel, you multiply this one and solve. So any of these two gets cancelled and you can equate this one, you will get. Okay, we move on to the next slide. Right. So this is also same as what the previous one. So that question only. Right. Then now even this one also let us take. Let us take photons. So photons with the energy 5 electron volt incident on a cathode. In a photoelectric cell, the maximum energy emitted photoelectron is maximum. So this is what 2 electron volt. When photon energy, this one is what? 6 electron volt is falling on that. Incident on this one is what? Cathode. Then no photoelectrons are emitted. Will reach the anode. Okay, this is anode. If the stopping potential of A relative to C is, stopping potential of A relative to C is asking, then what we can write? This is the, you can calculate the work function. So this work function is what? 5 is equal to W plus 2 or W is equal to 3 electron volt. This is the work function. This is also work function. So because the same surface, 6 minus 3 becomes what here? So this is about what? 3 electron volts we have. So let us take what about the Ke max? Ke max is equal to 3 electron volt, or EV naught is equal to 3 EV. As EE cancel, V naught is equal to 3 volts we have. But he's asking what? Anode with respect to cathode. So what about the anode potential? Anode potential you should be given. If it is what? Positive, then electron flow will be there. But anode should be given what? Negative. That's why what should be this one? Stopping potential? Negative potential. That's why it should be what? -3. Anode potential with respect to cathode, it becomes what? -3 volts. Okay, we move on to next slide. So this one you have to remember about. And one important point I want to discuss here. So let us take very important. Look at here. You can expect this one. Let us take what work function is. Let us take 5 electron volts. Remember this one. This is about very important. So this type of question definitely they ask what in the coming exam. Let us take what here. So this one is what 3 electron volt is what falling on that. Can you get the photo electrons? As this energy falling is what less than the this one work function, you cannot get the photoelectron. That's why photoelectron you cannot get. Of course, this one we know, but most important, let us see what they may ask. What this one is what in NEET. Let us take. So this is 3 electron. Of course, same question I am asking. 5 electron. Now one more is what 4 electron volt is what falling on that. Can we get the photoelectron? Most important. Let us take. So if it is what 4 electron, it is falling. Can we get the photo? Work function is same, 5 electron also only. Can we get the photo electrons? Yes. So look at here. But it is very dangerous. But once if you 3 plus 4 is what 7, as 7 is what more than 5, that's why we can get the photoelectron, which is not at all correct. So that's why what we get, you cannot get the photoelectron. Once if it is what this one is what energy is falling, it is absorbed, then it won't receive what another this one. That's why you never get what. So energy, this one photoelectron cannot be obtained. That's why it is what you must have to take what this one is what very important. As 3 plus 4 is 7, 7 is what more than work function. No, that's why we can get no, which is not at all correct. So this must have to remember. This is very important. So may ask what in NEET. This. Okay, right. We move on to the next. Now, so of course, this is also the same as just now we discussed. A with respect to C. Even this also you can calculate about the same thing, same as what the previous. Okay, so same thing. HC by lambda is equals to what we can write. So this W plus EV naught. Based on that we can. And now, so let us take what here. Now we come to, so this one is what de Broglie wavelength. Okay, so in this de Broglie wavelength, let us take this one is, so light of wavelength 500 nanometer is incident on a metal with work function. This one, the de Broglie wavelength, is asking the combination of photoelectric effect and also de Broglie wavelength. Let us take, so let us take what this one is what wavelength of 500 nanometers. Is incident on a metal. This one is what work function is 2.28. Similar to this one is what 2026 NEET exam. So this is what, whether it is what, let us see this one. What about the maximum kinetic energy? This is up to this one is, up to this is. So it is what photoelectric effect. Then after that, it is what de Broglie. Let us come to this. So let us take what 500 nanometer is falling on that. This is electron volt. Then, so first we have to convert this one into, so let us take what here, energy. We can take 500 nanometers means what we can write. And what about the kinetic energy? 12,400 by, this is not 1240 divided by 500, because, so this is given in nanometer. Once it is given in nanometer, 1240 by that. Otherwise it is what, if it is given in angstrom, 12,400 we can take. This is about what energy, that is what falling on that. So let us take what here. So this one is what cancel. So if you multiply with the 2, this is what 248 by 100, which should be equal to 2.48 electron volt. Okay, this energy falling on that is 2.48, whereas work function is 2.28. Definitely we get the photoelectron. Then what about the maximum kinetic energy of the photoelectron? You get 2.48 minus 2.20 becomes what? 0.2 electron volt we get. Okay, so this is about 0.20 electron volt we get. This is the maximum kinetic energy of the photoelectron coming out. Then what about the de Broglie wavelength of that electron? So just now I said, what about the de Broglie wavelength of for electron? De Broglie wavelength for electron 12.27 by root V we can write. Or even this 12.27 also you can take it what under root also we can take, which is equal to 150. You can write root over 150 by V also we can write, because 12.27 whole square is what nothing but 150 you can write. Say this is about root V. This is 12.27. So divided by root V. I already told that is what electron volts and volts is what same. 100 volts is nothing but 100 electron volts only. Then we can take it as what here 2.48 2.48 under root this one. Of course, this should be in. So this is what electron volts we can take, but lambda is asking what in meters. So you take what this one is what in. So this is what you get in angstrom. Of course, that you have to convert. Let us take what here 2.48 into 1.6 into 10 power minus 19 we can take. So then, so let us take what here 12.27 divided by, of course, 12.27 divided by, let us take, yes. One second. Yeah, this one. Yes. Okay. Right. No problem. Then let us take, so one thing, yes. So let it be that. Now, let us take what previously what we discussed here. Then, so let us take what here. This is what just now we have discussed here. Ke max is equals to what we got? 0.2 electron volt we got. Then, so lambda is equals to what we can write? 12.27 by root V we can write. So as this is what lambda should be in angstrom, and also this one is what in electron volt, then you substitute, then you this one is what lambda you get. As you are getting what this is what Ke max, as this is what Ke max means what this should be minimum wavelength. Now you substitute this one and simplify. This should be what minimum wavelength. So it should be, because the Ke is what maximum, as this is maximum means what this should be minimum. So that should be the minimum means what it should be. Minimum is this. It should be what greater than that. Then only we can get. So the answers whatever it is given, it should be greater than that. Of course, in the previously, of course, it so not then what is given in that? All options are given. So this is what more than that, but only one option they give what less than that. That we can opt that one. Okay, so that is the way we can do. Right. So now we come to, let us take what this one. Let us see. So when energy of the incident radiation is increased by 20%, then the kinetic energy of the photoelectron emitted from a metal surface increased from 0.5 to 0.8, the work function of the metal. So the same thing you can write. So this is what Hc by lambda is equals to W plus 0.5. Then, so this 20% is increased. 20% increase means what? So originally is what 100% means what 100 by 100 we can take. This is, and this is what 120 by 100 we can write, or 1.2 Hc by lambda, which should be equal to W plus 0.8. So he's asking about which one? What about the work function is asking. Okay. So then we can take it as what here. So this about the work function. Of course, this is what Hc by lambda, and this is what 1.2. We can take it as what Hc by lambda is equal to W plus 0.5, and this is 1.2 Hc by lambda is equal to W plus 0.8. So wherever this Hc by lambda is there, I can substitute in this, then we can get. So this is what W plus 0.8, and solve this one, you get this about work function you can get. Have understood this one? Like this you have to remember. So about this is the way we can do. Next one. Whenever it, suppose 20% is what decreased if it is given, you have to take what 80 by 100. From that we can calculate. Of course, you have to equate this one, and we can get the work function. So we move on to the next one. Yes. So, and let us take the kinetic energy of the particle increased to 16 times the previous value. The percentage change in the de Broglie wavelength. It is simple. Lambda is equal to h by root of 2m Ke. Then lambda 1 by lambda 2 is equal to Ke1 by Ke2. Then lambda 1 by lambda 2, that should be equal to Ke1 is E, and 16 times if it is given. Of course, this is Ke2 by Ke1. This is what 16E by E. Then you get lambda 1 by lambda 2 is equal to 4. Okay, so this one is what 4. But he's asking about percentage. If the original is 100 by lambda 2 is equal to 4, lambda 2 is equal to 25% is there. Then what about the change in the de Broglie wavelength? So originally if it is, this is what 100 is there, as we took what lambda 1 is 100. Now lambda 2 becomes what 25%. What about the change in the, so de Broglie wavelength is 75% is the change in the de Broglie wavelength. Okay, this type of question. So whenever if they, this is what, whenever they give what in percentage, take this, whatever they is asking what in percentage, that original or initial you take it as what, 100. Okay, we move on to the next slide. Let us see. So yes, so these things are important. One thing you have to remember. So whenever yes. Now, even I want to discuss even the graphs. So even this one is also important. Just now I said. So this is what electron. Whenever electron is asking nanometer is what 1.227 by root V, we can write. As it is what root V is equal to 1.227 by lambda E. So then you can take what here and we can get the voltage we can get. So that you have to remember about. So about the electron. Okay, if it is nanometers given, it is 1.227 by root V, or in angstrom is given, it is 12.27 by root V we can. Right. Now, let us take this graph. If you see this one is, so as lambda is equals to, we can write it as what? H by, so P we have. Then it's a graph between lambda to P is asking. So how they are related, lambda and P? Lambda and P is inversely. Whenever inversely proportional is there, the graph is rectangular hyperbola we get. So even the previously they asked one question, lambda, whenever it is what inversely proportional. So you just remember A proportional to 1 by B. If you are taking the graph between A and B, the graph is rectangular hyperbola. Whenever A proportional to B is there, as you are taking between A and B, the graph is straight line passing through origin. For example, instead of giving this one is what lambda to P, as lambda and P are inversely related, that's why the graph is so rectangular hyperbola. Suppose if it is given like this, so whenever, suppose if I am asking question, lambda and 1 by P, if they ask what in lineage, then what type of, this one is what you will get. Lambda and this one is what P. Lambda is what one quantity, 1 by P is what another quantity. Then what type of graph you will get? As I told here, directly proportional. The graph is straight line passing through origin. So the graph is straight line passing through the origin we get. Whenever directly proportional is there, it is straight line passing through origin. Whenever inversely proportional is there, it is so hyperbola we get. So and also one more, it is A proportional to B square is there. You remember this one. Whenever A and B if it is given, so then this one is what? So it is so parabola we get. Whenever so directly proportional but powers are not equal, it is what parabola. Directly proportional but powers are equal, it is straight line. Okay, if it is inversely, it is hyperbola we get. And one question asked in the previously, or you may ask, you may get, so this type of thing also, that is lambda is equal to de Broglie h by root of 2mke. Then if I am asking question, so let us take what they may ask what in lineage. So lambda and the root of ke if it is given, then what type of graph you get? Lambda and the root of ke, or lambda and 1 by root of ke first we take. 1 by root of ke. What do you have to take? So what is the relation we have? Lambda proportional to 1 by root of ke. As I told, if it is directly proportional is there, the graph is straight line passing through origin. Lambda and 1 by root of ke, both are, this is what one quantity, this is another quantity. As the directly proportional is there, what type of graph you get? Straight line passing through origin we get. So this one you have to remember in this whenever if it is given. Or let us take what if it is what, let us take what in this. Suppose if I am giving the question lambda and also root of ke if I am asking. So what we get? Lambda proportional to 1 by root of ke. This is lambda, this is root of ke. As they are what inversely proportional, the graph is hyperbola we get. This one is what you get. And also previously they asked one question. Let us take, so whenever this is what lambda, just now I said, so lambda square if I take proportional to 1 by ke we have. This is what squaring means, what it is ke. So then ke proportional to 1 by lambda square. So ke to, let us take what 1 by lambda square if it is given. Then what type of graph you get? As it is what ke and 1 by lambda square is what directly proportional. As it is what directly proportional, the graph graph may, so this one is what graph you get, straight line passing through origin we get. And if I ask what one more, so whenever if it is what they may ask what any graph in RENEET, let us take what KE and 1 by lambda if I ask. So KE to 1 by lambda, then what type of graph you get? KE to 1 by lambda square is straight line. KE to 1 by lambda is what type of graph you get? Let us see. This KE proportional to 1 by lambda whole square I can write. As I told here, A proportional to B square if it is there. This is KE one quantity. As this is what 1 by lambda one quantity, but square is there. Therefore, what type of graph you get? It is what? So parabola we get. So this one is what? So parabola we get. These things what you have to remember. One question if they give, you have to so know this is what type, this one what type of question we may get in future. That is the way you always you have to so concentrate while discussing what the previous papers. You must have to know what question they ask, what they are going to ask question. So where they have not touched till now. All these things we have to so discuss. Then definitely. So those questions only you will get in the exam. Okay, right. Next, one more. Let us take, even this is also the same thing. So de Broglie wavelength associated with an electron. Again, electron means what we can take 12.27 divided by root V. As it is given in nanometers are given, no. Therefore, lambda is equal 1.227 by root of 81. Simply 1.227 by 9. So then we can get what? 9 ones are 9. Let us take. So this way we can take what? 0.1 something. Yes, this is the fourth option we get. Understood this one? Yes. So let us come to another one. Let us take one more point I want to discuss about the right. Yes. So even, yes, just now I said, so what about the 1 by lambda square and also E? What about, yes, this is the 2024, just we were discussing. So like that, 1 by lambda square and also, just now I said, no, lambda is equal to h by root of 2me. So squaring means what we get? Lambda square is proportional to 1 by E, or E proportional to 1 by lambda square is taking the graph between E and 1 by lambda square. As they are directly proportional, what type of graph you get? Straight line passing through origin. Okay, this way we can remember. And one more last point we'll discuss. So this one is what you have to remember. Directly proportional straight line, inversely proportional hyperbola, proportional to if the powers are not equal and squares are there or cubes are there, it is the parabola you get. Right. One. Yes. About the graphs, this one you have to remember, these are the important. So as a, if you take the graph photoelectric effect, as a photoelectric effect 2, let's take what stopping potential. So this one is what stopping potentials are different, but what you will get, so this photo current is what same for different stopping potential. Stopping potential does not depends upon, so this one is what photo current, or so this one photoelectric current, it does not. They are what different, but so saturation current will get. All have what same current. Okay, so this one may be what different because frequencies are different. As the stopping potentials are different, frequency is related to stopping potential. That's why this stopping potential is what more. That's why frequency is what more. This frequency next this frequency. But so this one is what current is what same. This one I want to discuss, and also even here. So stopping potential is what same for both, but here is what current. As the stopping potential is same, this one is what currents are different. I1, I2, I3. As I3 is what intensity. This one and I3 is what corresponding, this one is what current here, corresponding current here, corresponding current here. As the current is what more here, that's why as the current is more means what this one intensity is also more. I3 is greater than I2 is greater than I1 you get. These things what you have to remember because stopping potential is same, but intensities are, photocurrents are different. That's why intensities are also different. Then, so one more important, as a photocurrent to intensity. So intensity is directly proportional to current. So that's why we get this one is what current, photocurrent to, and also intensity is what, as it is what directly proportional. That's why the graph is the straight line. So passing through origin we get. Even, so what about the kinetic energy too? So this one is what frequency. And one important point I want to discuss here. So whenever kinetic energy is what given, so this is kinetic energy and also this one is what frequency is given. So the graph, what you will get, this is important. Everybody should have to remember this one is. So this is what H nu or E is equals to what we can write, W plus, so Ke we can get. Of course, this is about what Ke max or maximum kinetic energy we get. This is what H nu is equals to W plus Ke we have. So R, which we can write as what in terms of frequency is given, W plus Ke we get. If you want to get, so frequency, there are but two variables are there. One is Ke, another is frequency. One is kinetic energy, another is frequency. What you have to do? If you keep what one is 0, I can get the other value. Let us take what here. Suppose if I put Ke is 0, then H nu is equal to W, as nu is equal to W by H we get. So whenever you keep what Ke is 0, you get W by H. It is a positive this side. Now, if you want to get the Ke, put nu as 0. As nu as 0, Ke is equal to minus W. Kinetic energy is negative, but this is what positive side and this is negative side. Then you get this about W. The graph is you will get like this. But you must have to remember, if it is in NEET, if it is given, you should not go to what this graph is what downside. Why? Kinetic energy can't be negative. That's why you must have to show like this. So this one is what question is given. Even this is what shown another the graph. You should not give that one. So you should have to give what like this only, because kinetic energy can't be negative. It should not be represented. So therefore, what about the slope of this graph? Slope of this graph means what? Slope is what? Y by X, or this W by H we have. W cancel. What about the slope of this graph is H we have this one. Even stopping potential to frequency, if they asked. So stopping potential to frequency. This is about stopping potential. This is frequency. Then what we can get? So H nu is equals to W plus E V naught. Similar way we have to take. These are variables are frequency and stopping potential. If two variables are there, if you want to get one, keep another one is what? 0. Suppose if I want to keep at stopping potential 0, I'll get the frequency. As frequency is equal to W by H, this is what W by H we have. And also we can take it as what here. So if you want to get V naught, put nu is 0. Then V naught is equal to minus of W by E, as this side is what? W by E. So therefore, the graph you will get what? Like this. Then, so what about this one you will get? What about the slope of this graph? Y by X or W by E by W by H, which should be equal to H by E. So therefore, slope of stopping potential to frequency is H by E, whereas, so this kinetic energy to frequency, the slope is H we get, which is the Planck's constant. You must have to remember these things. Okay, and suppose one more if it is given, let us take what here, one more graphs are given like this, suppose 3. So here stopping potential is, this is what? Less, as stopping potential is what? This one is what? Frequency is what? Less, because frequency this is, so as the frequency is less, work function is less, that's why what we get, so energy is equal to W plus Ke, or max or stopping potential, as this is what? Less, therefore what we get, so kinetic energy is what? Maximum we get. Okay, maximum, this is what? So kinetic energy is maximum, as work function is less, that's why it's the maximum kinetic energy. So this is what? More work function, and kinetic energy is what? Less we get, because energy is conserved. Okay, so this will have what? Work function is less, that's why kinetic energy is more for this. Here is what? Work function is what? More, that's why, so its kinetic energy is less. Right, then let us stay, yes. Right. Just now I said stopping potential to frequency is also, the graph is like this. And the last point that I want to discuss, this is the most important. Yes, even so, de Broglie wavelength for thermal equilibrium. So with this heavy water temperature, this one is what? Lambda is equal to H by, so root of 2m Ke, where Ke is equal to 3 by 2 Kt you have to take, then lambda is equal to H by root of 3m Kt we get. This one you have to remember, lambda is equal to H by, so this one is what? Root of 2m Ke, where K is equal to 3 by 2 Kt. So we can take it as what? H by root of 2m into 3 by 2 Kt. So then we can take it as what? H by root of 3m Kt, which is important, you must have to remember. It is absolute temperature, by using the Kinetic theory of gas, we can write this what this one is equal 3 by 2 kT. Yes. One. And even that de Broglie wavelength and also photon and also this one energy, I want to show the relation. Just within 2 minutes, we'll finish this session. And you must have to work hard because this is a very good opportunity you got. In 35 days, you must have to think that 365 days, how you worked hard, that much. So that way, you have to work even 35 days means what you have to remember. Okay, 35 days equal to 365 days. It is got the opportunity. Whoever got more, so this one wants to get, suppose whoever got already 600 plus, they may get 700 plus. Who got 400 or something? So they have opportunity to, very good opportunity to, so get the free seats. That's why 35 days equal to 365 days. You must have to remember this point. Yes, once. Yes, this point is very important. So this one you have to remember. So let us take, by this we close. So let us take, even this one is what? Lambda for electron is h by root of 2m ERKE for electron in terms of the mass we get. So whenever photon is given, let us take what pH, I am taking what photon. This is what hc by E we have. So they ask what here, suppose if they have what same energies. Once if they have what same energies, if I take what square on both the sides, 2me and also lambda photon square is h square c square by, so this is about what E square we get. Or let us take what here, even we can take it as what, yes, even we can take it as what in this, right. So let us take what here once again, right? Lambda of electron h by root of 2me and lambda of E is equal to hc by E. If you take what square, so which should be equal to h by 2me, or E is equal to, we can write it as what here. So h by 2m into lambda E square we can write when E is equals to. Even E is equal to hc by lambda E we can write. So then, so if you equate this one, h by 2m lambda E square is equal to hc by lambda E, then we can write it as what? This one is what? Lambda of photon. This is for photon. This is, okay, that is for electron. Yes. So then we can take it as what here? Lambda photon. Lambda photon is equal to 2mc into lambda E square we can get in this. So of course, this is what lambda square is equals to what we can get in this. So this is what h square we get, which is equal to h square. So which also equals to h square, one h gets cancelled. Then we get, so lambda photon is equals to this one is what by h. So this is what most important you have to remember. Lambda photon, you have to remember. Don't this one is what? So derive, or this one is what? Most important. Lambda photon is equal to mc by h into lambda E square. You must have to remember lambda photon is directly proportional to lambda E square. So this is also important. What are the things you must have to remember? By this we'll close this one. Lambda of electron or particle is h by root of 2me. Second point you have to remember, so hc by E. And third point you have to remember, lambda photon 2mc by h into lambda of electron square. And fourth point you have to remember, lambda photon is proportional to lambda E square we can get. These are the very, very important you must have to remember. So let us take what in this. So this you have to, yes. You take this one, and one last point is always there. That point we will give. So should I? Yes, even this is the last point. That is what? Electron. So mass m photon, the ratio of de Broglie wavelength associated with them, electron and a photon. So electron and photon is equals to what we get? 1 by c into root of E by 2m. Based on that only we can get. So even, so that also you have to remember. This also you must have to remember as a lambda electron by lambda photon is equals to 1 by c into root of E by 2m. This is about very, very important. You have to remember. So these are the things you have to remember as I told previously. So in addition to that, you have to remember lambda electron by lambda photon is equals to what we get? 1 by c into root of E by 2m also we can. That is about the fourth point you must have to. Fifth point you have to remember lambda electron by lambda photon is equal to 1 by c into root of E by 2m as I gave here, so that you can see this one. Okay, so these things you have to remember. We'll close this session. Right, but these points are you must have to remember. So, and tomorrow we'll take part another session. So based on the previous papers, what we got and what we may expect and what are the things you have to remember. So these things are very, very important, and definitely you'll get those questions only. Okay, right, all the best.